As you can see in this video, we are trying to show a change in momentum as Vince raises his hand and speeds it up towards the ball as the ball is being thrown up into the air and the transfer of energy. And so we want to find out the change in momentum from Vince's arm to the ball. So what we did was we found the weight of Vince's arm, which was 4.9 kg. We found the weight of the volleyball, which was 0.27 kg. Then we found the initial velocity of Vince's arm and the final velocity. The initial velocity was 1.8 meters per second. The final was 5.5 meters per second. Doing the math, it was 1.8 meters per second times 4.9 kg Vince's arm. And our answer was 8.82 meters per second kg. And then we found the final, which was 5.5 meters per second times 4.9 kg, and we got 26.95. We then subtracted 8.82 from 26.95, and we got the difference of 18.13, which is the change in momentum of Vince's arm. We then found the initial velocity for the volleyball, which was 1.4 meters per second. Then we found the final velocity of the ball, which was 16.5 meters per second. With this math, it was pretty much the same thing. We did 1.4 meters per second times 0.27 kg. Our answer came out to be 0.378. For the final, we did 16.5 meters per second times 0.27 kg, and our answer came out to be 4.455. We then subtracted 0.378 from the 4.55, and our answer was 4.077, which rounds to 4.08, and that is the change momentum of the volleyball. We then added the changes in momentum from Vince's arm and the volleyball, and we got 22.2 as the total change in momentum from Vince's hand to the volleyball.
While smacking a volleyball, friction plays a big part in the time that the ball spends in the air. As we compare the two videos, the first video we see that the ball has quite a bit of topspin, causing the ball to push the air particles in a way that helps it accelerate downwards. This is done by snapping the wrist over the top of the ball. As we look at the picture depicted, we see that the ball is moving in the opposite direction of air, and since there is topspin, there is a low air pressure towards the bottom of the ball, while the air pressure on the top of the ball stays about the same. Because the change in air pressure, the ball rotates in a way that causes it to move downwards. Looking here, we clearly see that the ball spends more time in the air because the arch is much less curved. By striking the bottom of the ball, it rolls from the lowest point of the palm to the tip of the finger in a flat. Looking at this picture, we see that the ball is going the opposite direction of air, and since there is a backspin, we see that there is a low air pressure going off the top of the ball and a high air pressure on the bottom. This makes it easier for the ball to travel upwards, making the ball want to travel upwards. But because gravity at this point is still stronger than the sum of forces in the Y, the ball is still moving downwards, just at a slower pace. Here, we target the elbow as the volleyball is being smashed. Now we're trying to find the sum of the forces. First, we start with the sum of the forces in the x. Our equation is f of x is equal to mass times acceleration. First, we have to work backwards and look at the equation. Velocity final is equal to velocity initial plus acceleration times time. Our known values are t equals 1.5 seconds, mass equals 4.9 kg, velocity final is 5.5 meters per second, and velocity initial is 0. We plug in our known values, and we're left with 5.5 is equal to acceleration times 1.5. Divide each side by 1.5 to get the acceleration alone, and we're left with 3.66. Here, we plug in our known values to the f of x equation, and we're left with 17.93. Now, we move on to find the sum of the forces of the y. We start with the equation f of y equals mass times acceleration of the y. Again, we work backwards with v final equals velocity initial plus acceleration times time. We look at our known values. Time is 1.5 seconds. Our mass is 4.9 kilograms. Our velocity final is 2.2, and our velocity initial is 0. Plug in our known values, and we have 2.2 equals 0 plus acceleration times 1.5. The 0 disappears, and we're left with 2.2 equals acceleration times 1.5. Divide each side by 1.5, and we're left with 1.46 equals the acceleration. Finally, we're left with our known values, and we plug them in. F of y equals 4.9 times 1.46. So our force of the y is equal to 7.15. Now we move down. Since we have our sum of forces in the x and sum of forces in the y, we use our triangle. We put 17.93 and 7.15 on both the legs, and then we have to find the hypotenuse by using Pythagorean theorem. We go a squared plus b squared equals c squared. We have our a squared and b squared, so we plug that in, and once we solve, we're left with 372.8 equal to c squared. Now, we square root each side to get the c alone, and that equals 19.3. Finally, we're left with our force, and that is 19.3. After using the physics app on the iPad to figure out what the distance was of the elbow as it was smashing the volleyball, we were given that the distance of the x was 1.8 meters and distance of the y was 2.8 meters. So again, we go to our triangle and we are left with the two legs, 1.8 meters and 2.8 meters. We go 1.8 meters squared plus 2.8 meters squared equals c squared. Solve, and we're left with 11.08. Then we square root each side, and we're left with 3.32 is equal to c, and that is the distance. After finding our force and our distance, we're left with the work equation. So, we simply go work equals force times distance. Plug in our known values, and we have work equals 19.3 times 3.32. Overall, work equals 64.103 joules.